Okay, I've been collecting some data from the coronavirus cases, okay? And I've taken that data off the World O-Meter Info website, which has allowed me to build an Excel spreadsheet, which I saved as a CVS, so I could do this in open freeware, of active cases. Notice that this is active cases, not total cases, active cases and total deaths. So I've plugged those into the CVS and I've written up a Octave GNU little routine to plot that data. Okay, and you can see the data here as I bring it in here. Okay, so I say, what can mathematics teach us about this? This looks very much like an exponential function. So let's model it with an exponential function. So let's bring some simple math here. That is, the amount of people that are active right now are proportional to the early numbers of active people, a sub 0 times e to the kt, but we don't know what k is. But I originally started at k at t equals 0, but I decided for a better model to start a little further along and make my t0 at when we had actual 57 confirmed cases, because of the number of they weren't really testing everybody at the start. And when I run this for a 1 week scenario, okay, I come up with solving for k, I come up with 0.3232. After 2 weeks of data, I find 2.2595, and after 3 weeks, 0.2766. We actually want those numbers to be going in the opposite direction, but that's for another discussion. So I'm going to plot all of this, okay, those 3 cases of my models against this experimental data and see what it looks like. So you can see that my early models were lower numbers. That 0.232 was a low number. Okay, it got better as I went to 14 days and got better still, but it still looks like it might be a little bit low, and we really want that coefficient to actually go in the opposite direction. So anyhow, that's what the numbers will tell us right now.